All right, guys, so let's talk a little bit about some other type of inference we can do. The one thing we just kind of finished up was hypothesis testing, where you would test a claim about the population proportion in our case, and then you would use a sample proportion, remember p hat, and you would get a p-value from the doing the norm CDF, and then you could make a conclusion to either reject or fail to reject the null hypothesis and all that stuff. One of the other real big ones is this idea of a confidence interval, and this is more where you're trying to estimate an unknown population value, and all you have is a sample value. Okay, so you're not really testing a specific claim, even though you can actually use these to do that. It's more so just to get an idea of where something is. So let me give you like a little formula, and then we'll talk about where everything comes from and whatnot. But the formula to do this, and it's really not as complicated as it looks. You know, the formula is going to look pretty complex. Let me just write it out for you. It's p hat, and we'll talk about what all this stuff is in just a second. Plus or minus z star, and then times the square root of p times 1 minus p all over n. And hopefully that part looks familiar under the square root. Remember, that's the standard deviation. And basically the idea is what each of these things mean. P hat is the sample proportion, okay, just like it was before. That's the value that you can actually obtain from a sample. Okay, sample proportion. Z star we'll talk about in just a second here, but then this piece again, that is just the standard deviation formula of the sampling distribution. So let's talk about what that means. And there's actually one change, since in this case we are actually trying to estimate p. Okay, again, remember, p is the population proportion, p hat is the sample proportion. So in the standard deviation formula, it has p's in there, but we don't know p, so we're going to have to use the p hats that we know from the sample. Okay, so we'll do an example in just a second. And basically the idea is that you take some estimate, you take a p hat, you add and subtract. Z star is going to tell you, it's basically going to be like a fancy z-score. Okay, and I'll talk about where that comes from in just 1 second. There's a few different values we use for z star, and then it's the number of standard deviations. That's what a z-score is. Okay, and that's why that z star ends up getting multiplied by the standard deviation. So let me set an example up, I guess, and then we'll talk about what the z star is in a second. Okay, so here's a specific example. Let's say there was a recent survey of 1,012 adults, or randomly selected citizens, and they found that 38% believe in ghosts. Okay, so that 38%, that's going to be our sample value. We call that p hat, and we usually write it as a decimal, 0.38. It's a proportion out of 1 instead of a percentage. So that came from the sample, so that's p hat. And we know the number in our sample, n, is the sample size was 1,012. Okay, and we are going to come up with a 95% confidence interval. And what that means is we're going to come up with an interval of numbers, okay, like from a minimum to some maximum, some range. And our statement at the end is going to be that we are 95% confident that the true proportion lies within this interval we're about to create. Okay, and sometimes there are different confidence levels. 95% is a common one. Sometimes you want to be 99% confident. Sometimes even 90, or even other ones, but those are the three big ones. And those are going to be used to determine which z star value we're going to use. And again, we'll talk about that in 1 second. But the basic setup here is just going to be this. We're going to say, all right, the confidence interval is going to be, let me write the formula, p hat plus or minus z star times the standard deviation formula. But again, we're using p hats in place of the p's because we don't know p. Okay, so if we start plugging everything in, the p hat for this problem again is 0.38. Plus or minus, we're going to talk about z star next. I just want to get the rest of the formula in. P hat in here again is 0.38. 1 minus 0.38 is 0.62. And then the n value is given as 1,012. Okay, so everything's set up. It's just going to be like a calculator problem. You're just going to do 0.38 plus something, and then 0.38 minus something. But we do need to talk about what this z star is and where it comes from. Okay, so z star again is going to tell you how many times you're multiplying the standard deviation, okay? And really what it goes back to is something we've done previously with z-scores, and it depends on what your confidence level is, okay? And again, in this problem, we were going with 95%. So if we think about, let's just do a little sketch here. If you think about under a normal curve, let's say we have 95% of the data in the middle, right? We learned at the beginning of the chapter even that remember the 68%, 95%, 99.7% rule. So we know that there should be approximately 2 standard deviations away from the mean, right? There's some mean here. Within 2 standard deviations, right? 1, 2, 2 that way, we should have about 95% of the values. What the z star is, it is actually just this z-score of this upper value here. And it's actually very close to 2. When we do this type of problem, though, we're going to get a little bit more accurate because it's not exactly 2. That rule back in the beginning said approximately. And the way we're going to find it is just by doing an inverse norm. Okay, and the good news is there's only going to be, I'm going to give you guys 3 different z-star values that we're going to use. There'll be one for 90%, one for 95, and then one for 99. And then those will be the 3 that you just kind of use. And I'll even provide those to you guys. But I just want to show you where it comes from once, because it is something similar to what we did before. It is just an inverse norm. And we're going to ask ourselves, whenever you do inverse norm, you're saying how much area is beneath your value. And then since it's a z-score, we're going to use a mean of 0 and a standard deviation of 1. But the area beneath this value here is the 95% we have in the middle. That means there's 5% left over. So the 5% is evenly split. There's 2.5% down in that little left tail, and there's 2.5% in this upper right tail. So the area to the left here is this 95% plus 2.5 more percent. So it's actually 0.975. Okay, it's basically everything except that little 2.5% is another way to think of it. That's why it's 97.5%. And just to verify where this z-star comes from, okay, if we type that problem into our calculator, I'm just doing a inverse norm right now, and it's going to give me a value of, it's actually 1.9599, and we're just going to round that to 1.96. Okay, so you can see it's really close to 2, like we used again earlier. But we're going to be, like I said, just a little bit more accurate. We're going to go with 1.96. So any problem that has a 95% confidence level, okay, you will use 1.96 every single time. Okay. Okay, 90%, which is a little bit smaller, right? 90% would only be about here to here. So the z-score there, if you did the same process, you can just kind of take my word for it. The z-star for 90% that we will always use is 1.645. Okay, because it's not quite 2 standard deviations. It's less. It's only 1.645 standard deviations. And then the final one, the big one, if you ever need to be 99% confident, which some problems will say, let's be 99%. You're going to use a bigger z-star. That one, using the same process, should get you 2.576. Oops, let me write those down. Okay, so just keep those in mind. On any test or anything, I will provide those with you. But those are the 3. Anytime you see z-star, it's going to be one of those 3. I may change it to something not there, but it would be like an extra credit question or something at this point for us. Okay, so let's go ahead and finish this problem. Let's just do the calculation. I'm just going to go back and do this right here, put everything together. And it's basically just going to turn into a calculator problem. But what we're going to have, the problem, if we needed to be 99% confident, the only difference, okay, or if, for any different confidence level, you would just use a different z-star value, right? If you wanted to be 99%, you would be using a 2.576 level, 0.38. That was the estimate. They call it the point estimate. We're going to do plus and minus. Since it was 95%, we're going to do 1.96. That's the number of standard deviations. And the standard deviation, again, was the p hat times 1 minus the p hat over n. Okay, so I'm just going to type this in the calculator carefully here. And what you can do the 0.38 plus 1.96 times the square root part. And kind of just do these one at a time. And that's going to give me 0.4099 for the one with the plus. And then on your calculator, you can hit second enter, and it will put the expression back in. I'm just going to change the plus to a minus, just so I don't have to retype everything. And the one with the minus gives me 0.350. Okay. And what we just found, just by doing that simple little calculation, is we have found that we are, or the conclusion we can make, I should say, it would be written like this: we are 95% confident that the true, I guess we don't need a comma there either, getting carried away here, that the true proportion of citizens who believe in ghosts and here's how we word this. We just say, you can just simply say lies between, and then just those two numbers. We had 0.350 and 0.4099. Okay, so we came up with an estimate where we think, again, we just found an interval where we think the population value lies in between, right? We had this little sample value here, and that's all we really needed. We needed a sample value. We needed to know the confidence level, the 95% is where we got that from. And then the standard deviation, again, just came from p hat, 1 minus p hat over n. And we were able to, again, make an estimate. We think the entire population, okay, the proportion who believe in ghosts is somewhere between these two numbers. And as long as the sample, we should have checked this, and we'll actually show this, as long as the sample was random, that part we actually knew, the normal condition would need to be checked as well, but it's the same as before, okay? We should, let me throw that in here, I should have done that. To check that things are normal, okay? Again, this should have happened before we did the problem. But it's the same deal of n times p being greater than or equal to 10, and n times 1 minus p greater than or equal to 10. But again, the one issue is, and it's a small issue, but does need to be mentioned, we're not using p in here because we don't know p. We're using p hats. We're using the 0.38s in there. And if you check out the 1012 times 0.38, you'll see that it's definitely bigger than or equal to 10. And then same thing with n times 1 minus p. Okay, and you can just verify again, those are both greater than or equal to 10, but show that step first and state that it's random. That's checking the conditions. And then your results are, they're statistically, you know, legit. I mean, this is a true estimate where we think the true value for the population would be. Okay, so the good news is we're fairly confident, you know, 95%, we believe the interval's in there. Now the thing is, you never know for sure, right? So we don't know if we're 100% confident, you know, can't really do that. But going back to, so when we did our calculation, let's see if I can show this up here. When we did this up here, that number would have changed, okay? And it just would have made the interval wider, okay? Maybe instead of going only down to 0.35, it would have went like farther down, 0.33 or something. I'm not sure what it would be. But it would just make the interval wider, which is okay. It's, you know, you're not going to have as precise, but you needed to be more confident. That's the only way to do it, is to change the z star in there. Okay, one last thing, these can be done on your calculator too. So I just want to show you that step. If you go into stat over to tests, same place where we did the 1 proportion z test, you will see farther down in the list there is a 1 proportion z interval. Okay, and make sure you find the right one. There's a lot of different tests in here. And then what you need to do, the original sample given was 38% out of 1012. You need to actually do 0.38 times 1012 to get an actual number. Okay, so 384 out of 1012 is what we're going to call x. It's like the number of successes, basically. And if you can't read the n there, that's the 1012 that we knew. You can pick whatever the confidence level is that you want. And here's our results. They're slightly different because it's using a little bit more exact z star than 1.96. and it didn't really round anything, but it's pretty close to our numbers, right? We had 0.35 and 0.409 or something. You can see these are basically the same thing. Okay, so feel free to use that. And again, as always, feel free to email me with questions. We'll have you do a couple examples coming up here for practice. All right, thanks.